Welcome back, students. Welcome to our online class. So I hope you do remember me. I'm your teacher, Mel. Okay? So as a continuation of our lesson, we're about to discuss for today the lecture number 2 with the title, Factoring a Difference of Two Squares. I hope you're all ready. So for today's objectives, here are the following. Number 1, identify perfect square numbers. Number 2, factor the difference of two squares. Okay, so let's start with the student's activity. So identify the perfect square numbers among these. So from 1 to 10, which among these are perfect square numbers? One, 4, and 9. So these are the numbers which are perfect square between 1 and 10. Remember, a perfect square is a number that can be expressed as the product of two equal integers. So let's do the factoring a difference of two squares. So in mathematics, the difference of two squares is a perfect square number or expression subtracted from another perfect square. When we multiply a sum and difference of the same two terms, the product is a difference of two squares. Take note that the quantity n plus 3 multiplied to the quantity of n minus 3 is equal to n squared minus 3 squared, which is equal to n squared minus 9. The resulting product is a difference of two squares. In general, a difference of two squares like a squared minus b squared factors as a squared minus b squared is equal to the quantity of a plus b multiplied to the quantity of a minus b. So here is the pattern. You always remember this one. X squared minus y squared has the following factors of x plus y and x minus y. This is the sum and difference of the terms. So x squared minus y squared is the difference of two squares. That's the term for it. And x plus y, the binomial x plus y and x minus y is called as the sum and the difference of two squares. So how to factor the difference of two squares? So let's get the square root of the first term and square root of the second term. So the square root of x squared is x and the square root of y squared is y. So from x squared minus y squared, we can write it as first binomial, which is x plus y, and the second binomial, which is x minus y. So remember this pattern. So let's do the practice. Which of the following is a difference of two squares? So when we get the square root of x to the fourth, it will give you x squared. And square root of 9, it will give you 3. That's the reason. Okay, another one. 9x squared minus 25y to the 6th power. Is this a difference of two squares? Yes, it is. Difference of two squares. Why? It's because 9x squared and 25y to the 6 are both perfect squares. So the square root of 9x squared is 3x. And the square root of 25y to the 6 is 5y cubed. Third, 8x to the 6 minus 1. Is this a perfect square? No, this is not a perfect square. This is not an example of difference of two squares. So let's have another practice. Remember this pattern. X squared minus y squared is equal to the product of the binomials x plus y and x minus y. So let's have to factor the following. X to the fourth minus 9. So the square root of x to the fourth is x squared. And square root of 9 is 3. So we can write it by using the pattern given. So we can write it as x squared plus 3 and x squared minus 3. Number 2, 9x squared minus 25y to the 6th. Both are perfect squares. So we need to use the pattern, the product of x plus y and x minus y. So we will be having 3x plus 5y cubed, 3x minus 5y cubed. How did we get it? Just simply get the square root of each term. How about this? Factor 3x squared minus 12. As you observe, 3x squared and 12 are not both perfect squares. So we need to get the GCF of each term. The GCF of 3x squared and 12 is 3, and the remaining factors is x squared minus 4. X squared minus 4 is already a difference of two squares. So we can write it as 3 multiplied to the product of the two binomials x plus 2 and x minus 2. So this is the factors, or these are the factors of this expression. Hope you learned a lot today.